5, 4, 3, 2, 1.
Hello, thanks for tuning in and welcome to the Marple Autumn Summit. Welcome at our office here in Antwerpen. Finally, we can show what we have been working on over the past year. Marple 2.0 is here and we are excited to show you. Today we will be talking about the technical details and performance of our new products. We'll cover 2 customer cases, one in Motorsport and one in Aerospace. We'll do hands-on demos of using MATLAB and Python to do advanced computations on data in Marple. And at the end, we will reveal a small part of what to expect from us in 2026. 2025 has been a fantastic year for Marple. We expanded to 21 different countries, mostly in Europe and USA. We tripled our product revenue in only 1 year. Daily, more than 300 teams make use of Marple to speed up their development, and more than 200,000 tests and simulations have been uploaded, processed, and analyzed by engineers across different Marple products. If you say Marple, you say cutting-edge technology. We are proud to support the world's most ambitious R&D teams, building the next generation of technology. We support racing teams operating at the highest level in races like Daytona 24 Hours, as well as companies that design more efficient electrical motors. Marple is used in aerospace to do flight testing of eVTOL aircraft, but we also make our contributions in space exploration. In manufacturing, Marple drastically shortens development cycles in power electronics, compressors, battery design, and other products. But don't take my word for it. Let's take a look at some of the engineers using Marple.
Hello.
Hi.
Hello.
Hi, I'm Michael from Deep Drive, and we are using Marple to develop automotive drivetrains.
To analyze our test flights.
For CAN signal analysis in our e-bike systems.
To streamline the decision-making process based on data for flight testing.
For analysis of our 3D metal printers.
Develop the next generation of transportation.
Battery optimization.
Real-time sensing data analysis.
Visualizing data from our solar car and beat the Dutch next year.
The most powerful thing in Marple is the ability to share pre-processed data with the design office using the templates, the calculated signals, or the time markers.
API, which allows us to automate our data processing.
Accessibility through web interface and ease of use.
To interactively debrief the flight with the test crew immediately after landing.
How quickly I can turn raw data into clear insights.
We can collaborate in real time wherever we are.
It's how easily we can visualize and compare different time series.
To visualize our race data in a fraction of a second.
Data comparison tool and the database integration.
We noticed that engineering teams thrive when they can set up an open ecosystem, where different software tools can be integrated and customized. So to be able to grow, we decided that we had to open our own product. Today, we are introducing Marple 2.0, an open approach with 2 new products, Marple DB and Marple Insight. These new products are designed to be integrated into your workflow. Popular time series data sources, InfluxDB, Timescale, Microsoft Fabric, can be linked to Marple Insight. Using our SDKs, data can be extracted for further processing in MATLAB and Python. This opens up the possibility for advanced data mining and AI use cases. In a similar way, you can link data stored in Marple DB with external reporting tools like Power BI and Grafana. By leveraging our automations, you can set up automatic triggers to Slack and Microsoft Teams, making sure that the right people are informed about new data and test results. This is what makes Marple 2.0 so powerful. If you have any questions during the presentation, feel free to drop them in the chat. We'll try to reply to all your questions live or afterwards for the more complex questions. Now I would like to welcome my co-founder Nero to the stage for a closer look at Marple DB. Nero? Thank you. Happy to be here today. So Marple DB sounds like it's a database, but what is it exactly? Well, it would be more accurate to describe it as a data lakehouse. That's a combination of a data lake and a data warehouse. This means that it unifies the benefits of both in one solution. Data lakes are good at storing raw files, and do this at enormous scale. The warehouse part offers a structured approach to both data and metadata, which is optimized for very fast querying. Combining the best of both, Marple DB is scalable and fast. Today, I want to take you through how we actually achieve this in detail. But before we dive into what's under the hood, let's take a look at the bigger picture. Marple DB is designed with data coming from files in mind. If you are using an off-the-shelf logger or a custom-built data acquisition system, high-frequency data often ends up in files. These can be CSV, MATLAB, MDF, TDMS, or some other file formats that we commonly see. Generating these files is often the easy part, but engineering teams struggle to analyze them. They can be gigabytes in size, you need specific software to open them, and downloading them to your laptop can take a long time. Marple DB is capable of consuming these files directly and turn them into a standardized database that is accessible for anyone in the team. It acts as a central starting point for different types of data analysis. For exploration and root cause analysis, you can couple Marple Insight or other frontends like Grafana. For custom scripting, you can connect MATLAB and Python scripts using our SDKs. For users with real-time use cases, data packets can also be streamed directly to Marple DB. This opens up the possibility to do both live monitoring and post-test analysis using a single data solution. Marple DB can handle data from a lot of different sources. We solve this with something that we call data streams. A data stream is a configuration to import a specific file format, along with custom logic about how to process the data. For example, you can have data from a prototype vehicle in MDF files, and also simulation data in CSV files. In Marple DB, you create a data stream for both and select the right plugin for each file format. In case of the CSV plugin, you can configure additional parameters, such as a delimiter and the details about how to interpret the timestamps. You can even go deeper and customize the plugin yourself, in case you want to extract custom metadata, or if you want to do manipulation on the data before it's imported. Every data stream can also have post-processing enabled. This is a very versatile tool to enrich the data coming from your file. A typical use case for this is adding units, descriptions, or offsets and gains in the signal values. Even more powerful is using the signal aliases feature. You can use this to achieve a unified namespace, where all measurements comply to a common naming scheme. For example, the measurement speed could have a different name across data streams. If you define a consistent name for this in Marple DB using aliases, you can query speed in all these files by the same name. This makes it possible to do large data analysis campaigns because the data is clean and unified across all files. Clean data is even more important for AI use cases, where large amounts of data are needed for training. Even if you are not ready today to implement AI workflows, Marple DB already future-proofs your organization for these advanced applications. Every year, we see that our customers put more and more sensors on their devices. They are also capturing at higher sampling rates to analyze high-frequency effects. Test engineers rather log too much data instead of not logging something that might end up being useful in the future. And they are right about that. Marple DB is designed to face exactly this challenge. That's why we focused a lot on performance in shaping the product. To give you an idea, Marple DB can handle 200,000 measurements per file, sampling rates above 200 kHz, and file sizes of tens of gigabytes. Some of our customers have over 100 billion data points in one single file. But the best part is the ingestion speed. Compared to our previous product, we improved the throughput for data importing 25-fold, reaching speeds of over 10 million data points per second. This means that we now achieve top-of-market performance, outperforming other solutions for this use case in engineering. To give you an idea of how fast we can actually import data, think about this. The Apollo 11 mission streamed about 500 million data points per 24 hours, and importing all of this data into Marple DB takes less than 1 minute. That is a huge step for engineering. The second part of handling massive amounts of data is that you must be able to store all of it. Classical database storage is fast, but also very expensive. That's why for Marple DB, we came up with a solution that is both fast and also scales up to hundreds of terabytes of data. Our approach is a custom architecture that combines hot storage in Postgres and cold storage in Parquet files, purely optimized for storing time series data. Parquet files have the advantage of allowing high compression, and they can be stored on object storage like S3. This allows us to be very competitive in pricing. For end users, we provide direct access to query the Parquet storage, which is suitable for large data mining campaigns. Accessing the storage can easily be done using our Python and MATLAB SDKs, or using our API for connecting from other languages. Let's take a look at how that compares to our old solution. When upgrading customers to Marple DB, we see that our new approach is 5 to 25 times more efficient in space usage, depending on the use case and configuration of the customer. And if a test campaign is over, datasets can be archived in bulk, again decreasing the cost of storage. With Marple DB, we defined a fundamental new way to how engineers can store the time series data. One of the first teams that adopted Marple back when we started is the Formula Student team of Delft. So let's take a look at how they are using Marple to get the most out of their car.
So my name is Anne Schoenberger, and I started last year on the .25 working on the control system, so doing a lot of data analysis and refining the software of the car. And this year I continued for the .26 as the chief electronics. I think the car is a really exciting engineering challenge for students because they can actually put their theoretical knowledge that they got in university in practice, and they can design and build something that actually has to perform well. So you have to think about a lot more details than you normally do in a university project, for example. I remember in Germany, which is for us the most important competition of all, we were watching the endurance and the car was driving, and for us the endurance is the most important event of the whole competition because it gives us the most points, and not finishing it means you can't win. And I remember watching the car with the team and just hoping that it would finish, and then every time it was driving by we were screaming at the driver to go faster, faster, just drive it home. And then the moment it actually crossed the finish line was the most ecstatic I've ever felt, I think. It was incredible. I think the hardest part of the car design is actually making it all work together. It's really easy to design a single part that has to do something in and of itself, but getting it to work within the whole system and also getting it to work well within that system is very tough. For our team, data is really important because it actually allows us to tune the car to its optimal performance. We need to do setup changes because there is an optimal setup for specific conditions and for a specific track. And during testing, we try to find that optimal setup, which we need to do by analyzing data. So having good data and a good way to visualize that data is really important for us. As a team, we need a very performant data storage system to be able to handle all of the data that we collect during testing. Because on one testing day we can collect tens of gigabytes of data, and that accumulates to a lot of data over the course of our testing season. So we need a system that is able to actually handle all of that data. The data actually we collected real time and also send it to Marple DB in real time, which is where we also can watch the data of our car and actually keep track of what is going on from the side of the track. So the data from our test bench, where we can test our motors and motor controllers, goes into Marple DB by first storing it locally on a computer, which we can then upload those files into Marple DB. The format that we collect those files in is either CSV or MATLAB, which we can both very easily import into Marple DB. In Marple DB we have data from the past 10 years, so going back to the .16. From all the testing seasons that we had and all the competition seasons that we've had from those. So it's very easy for us to also look at other cars and look at what they did and their setups and how that affected everything. It is very useful for the team to have all the data in a central place, because then we can easily collaborate on the data analysis. We all see the same thing and we can all analyze the data in the same way, so we can come to the same conclusions hopefully. So we also use Slack to communicate with alumni who can help us during the testing season and during competitions. If we have any questions about data, if we see there's something wrong or there's something weird in the data, we can very easily send a link to the data. They can look at the same data, so they can help us more effectively than when they have to go look for it themselves and maybe see something slightly different. For the team, the MATLAB and Python SDKs of Marple DB are very important, because for our vehicle dynamics models, for example, it is very nice to be able to use all the data from a certain car to estimate certain parameters. And with Marple DB, we can call all the data of a certain car very easily into our code and then are able to estimate those parameters. In the future, we want to be able to get more out of Marple DB by using the same data flow that we use for our models, but then for an AI model that we can train to better estimate those parameters. I think in the coming 10 years, motorsport engineering will change a lot, because we want more and more data each year. And that means that we probably get more sensors on the car, or data gets sent at a higher frequency, meaning that we need systems that are able to handle all of those extra data points.
Amazing to see how they are achieving high performance both on the track as well as off the track using Marple DB. Now, let's make things a bit more exciting. It's time for a hands-on demo. Please welcome Karen, who is going to show you just how powerful our SDKs really are. Karen?
Hello, my name is Karen. I am a software developer at Marple since about 3 years. And today I will do a demo of how to use Marple DB SDK. So what I will do is I will start with some files, push those to Marple DB using the SDK. And then once our data is in Marple DB, it's nice because no matter the file type it started from, it will all be in one structured, nice way and accessible to a lot of tools that are out there, for example, Marple Insight. But for this case, we will connect Marple DB with MATLAB and do some deeper analysis there. The case we are looking into is a wing deflection test on Airbus aircraft types. And more specifically, we are looking into 3 aircraft types, the A319, A320 and A321. So I have gathered some data, and 2 of my 3 aircraft types use a logger that streams the data into an H5 file, and the 3rd type creates a CSV file with the data. So that means that already to start from, the data is in 2 different file formats, which is no problem at all. Once we have the data in Marple DB, the case that we want to look into is the damping ratio of the wings. So let's get started. We are looking at this point at Marple DB, and you see here 2 data streams. The data stream is a way to flow data from files into Marple DB. As I mentioned, there are 2 aircraft types that have loggers logging into H5 files. Those datasets have already been added here. I already prepared that. You can see I have some datasets lined up here. And we also have a 3rd type which logs into CSV files. Those we still have to fill into Marple DB, and this I will do now using our Python SDK. First thing to mention is that the loggers log into a different file type, but also they use different signal names. That is actually not a problem, because in Marple DB you can fill in what we call a signal alias. And this way you make sure that there is one signal with like a unified name in all of your datasets, which you then can use to do all other things on your dataset afterwards. So we want to look into the wing deflection. So we need the wingtip placement in all of our files. In the first loggers, this is called wingtip placement, and in the CSV logger, this is called differently. So let's quickly set up a signal alias here. The alias I want is wingtip placement, and in our CSV logger, this is called string. So now, if the data comes into Marple DB, there will always be one signal called wingtip placement. Now I will use our Python SDK. For this, I can simply create an API token here and then connect to it. Here you can see my Python script. This is quite simple. From Marple import DB, so we are talking to the DB SDK, filling in our API token and URL, and then I say stream to this name that we already saw before, and then we will loop over all the files in a folder that I prepared, add some metadata, and then we're good to go. So let's run this thing. Let's go. Okay, perfect. If I go back to DB, you see that indeed 10 datasets have arrived. Some are still waiting to be imported. This goes quite quickly. Normally, Marple always ingests quickly, but normally we use much bigger files. For this demo, it's quite like this. So let's see a quick sanity check in Marple Insight. You can see that indeed the data is present, the ingestion worked fine, so all is well. Move on to the second part, where I will use MATLAB to connect to this data in DB. There's a lot of documentation about the MATLAB SDK on our website. The most important thing to know for now is that it's packed as a db.m file, and I've already imported this into my MATLAB setup. I have configured everything to Marple DB as like the API token and so on in this config.json file, and then I can use it into my MATLAB script and directly get all the data I need from all my different file types. So let's get into it. Here I list the streams I want to include in my tests, and I collect all the data sets for all those streams. And then for every data set, we will calculate the damping ratio of the wing. So this is actually where the magic happens. Here we connect to the Marple DB SDK and get the data for the wingtip placement. Remember the signal we just made sure we have in all our data sets. Then we will use this in our calculation, store it, and in the end make a nice box plot out of it to look into the damping ratio of all our tests. So now we have put it all together. Let's run this script. See, the data sets are being processed, and in the end, indeed, we get a nice box plot, and we can see, for example, the A320 has a much bigger variation on the damping ratio. One thing to mention, we fetched this data from Marple DB, but it's also stored in a local cache on your laptop, like you can see here. And this is nice because now probably I want to dive more into the data. I don't have to fetch it again. I can just use it from my local cache and continue my investigation. So that's about it, what I wanted to show you. Thanks for watching.
Thank you, Karen. That was really a great demo, showing just how powerful and easy it is to use our SDKs. At the start, we promised you that we would cover 2 products today. So far, we already talked in depth about Marple DB. So now I'm excited to show you Marple Insight. Marple Insight is a web interface to visually interact with your data. It is the evolution of the product that many of you have used and loved over the past 5 years. The feedback that we received time and time again is that people wanted to integrate Marple with other databases. And Marple Insight can exactly do that. You can set up a connection with our own Marple DB or third-party databases, including Timescale, InfluxDB, Microsoft Fabric, and ClickHouse. The integration is completely customizable by configuring 3 essential queries as an admin. These queries tell Marple Insight from what tables or views to extract the data. As an end user, there is no need to know any coding. Every action can be done by drag and drop, clicking and scrolling. Even though we generalized our whole product to enable these integrations, we did not have to sacrifice on performance. Behind the scenes, we do incredible optimizations on the queries. Let's take a look at a screencast that I recorded earlier today. In this example, we are visualizing a measurement at 100 kHz for a total of 1 million data points across the whole time range. If we zoom into a smaller data region, you can see that we get an updated time trace in less than 1 second. This footage is not sped up, not staged, and we are happy to give you a live demo over a call. A second point of feedback that we took to heart is having extra functionality for key markets. For Motorsport and Automotive customers, we introduced a toolbox that expands the functionality of Marple Insight. This includes lap support, with easy comparison between different laps, distance mode, to graph over distance instead of time, and the ability to load track maps as a background for the map plot. For aerospace and flight testing users, we also offer a dedicated toolbox. These engineers are getting extra value by the ability to show different flight phases, such as takeoff, landing, and certain maneuvers. Additionally, they can see a 3D view with the orientation of the aircraft and a primary flight display for easier interpretation of the data. A big change in our product vision this year has been to shift the focus from analysis of individual datasets to getting insights across a whole test campaign. Because that is the strength of Marple Insight. It is connected to a database and therefore has access to data from thousands of tests at once. That's why last week we shipped a feature called Overview Dashboards. In an overview dashboard, you can make visualizations across hundreds of datasets at once. A typical use case is to track the progress of a test campaign. In one view, you get a top-level insight showing what regions of the test space have been covered so far, and which tests behave like outliers. This is a game changer, because it's always up to date on your actual test data, in contrast to a static report that is compiled once every month. To create an overview dashboard, you can combine dataset metadata, aggregates on measurement values, and custom math calculations. And what is the best thing about these dashboards? They are cached, which means that every time you open them, all the results are instantly available. A final topic that I want to cover today is reporting. Over the years, we have seen a lot of our customers building automated reporting flows on top of Marple. And this makes sense. When you record data, there is typically a set of thresholds that you want to check to validate the measurements. Often, you also have key graphs that you want to see to judge if a test was successful or not. Before the end of the year, we are shipping the ability to generate these kind of PDF reports directly from Marple Insight. These reports are based on a template. As a user, you can configure what graphs you want to have included and what conditions should be checked. For each new dataset in a database, a report is automatically generated. Based on rules, you can choose to email the report to certain people or push it to collaboration tools like Slack and Teams. Clicking a graph inside the PDF gets you straight to Marple Insight, where you can interactively investigate the data in more detail. This will enable engineers to integrate Marple closer in their workflows and let them collaborate better than ever before. Recently, we were invited at the offices of AeroDelft. They are using Marple Insight and its new features on a daily basis with the whole team. Let's have a look.
Hello, I'm Martijn Kochhout. I am the Chief Flight Testing Engineer here at AeroDelft. So I am responsible for the qualification process of our aircraft. So that's everything from lightly involving in systems engineering and requirement forming, through to the qualifications of the systems at the end through the testing campaigns. The mission of AeroDelft is to prove and promote liquid hydrogen as a sustainable alternative to conventional fuels in aviation. And the way we are doing that, as you can see around me, is we are manufacturing our own liquid hydrogen powered plane. It will first be flying on gaseous hydrogen. That is because gaseous hydrogen is slightly easier to work with than the cryogenics of liquid hydrogen. But we expect that after July next year, we'll be integrating our liquid hydrogen into the plane so that we can fly on it the year afterwards. We track the progress of our test campaign using data sets and using Marple. So we start off with our requirements and our components, and then we go through into test plans where we determine what kind of data we need to collect from our tests. We physically run the tests, and then afterwards we take the massive data that we receive during our test, and we have to somehow relate the data we get back into the requirements that we set in the first place to be able to validate that the system is working the way we expect it to. And for that we use different types of APIs from Marple, which allow us to automatically validate requirements from the data without having to manually go through it anymore, which gives us increases our efficiency in our testing campaigns. We are using different features from Marple to overview our entire test campaign. For example, we're using the overview dashboard. We are using that to visualize our data sets so that we can immediately see the test conditions that we have done, and by that extrapolate the test conditions that we haven't done. And we can immediately see if we need to do more extensive testing or if what we have is sufficient, which once again improves testing efficiency, which makes me as testing engineer very happy.
Hi, I am Sippe and I am an electronics and software engineer at AeroDelft. So at AeroDelft, data is important because we do a lot of testing, and we use the testing data to demonstrate to the flight authorities that our system is safe and it works well, so that in the end we can hopefully obtain a permit to fly and perform our test flights. Marple Insight allows us to work with high precision data because we can just take the raw data and put it into Marple, and our engineers can very easily just take the raw data, drag it into Marple, and it shows up as a beautiful graph that we can show in our reports as well. The efficiency of our workflow is improved a lot because we can do our data analysis at the same time as our testing is being performed by having people at the office do the data analysis. And this allows us to also perform a new test if necessary, as opposed to having to analyze the data manually and then having to drive back to the testing location. And it saves us a lot of time this way. With Marple Insight's reporting feature, we can easily check if we meet our requirements. So we can set a threshold for a certain value and then see if we are above or below that value, and so see if our requirement is met. We're automating these reports by automatically sending over a PDF to our flight test engineers who can review the data for quality and who can also say that we need to perform a test if necessary and check if we meet the requirements that we were looking for. In the future, we're looking to integrate Marple more by integrating the API with our requirement management software so that our test data can immediately move into the requirement management software and prove that we are meeting our requirements for the flight authorities. Marple facilitates combining test data with simulation data with Marple database, where we can pull both the simulation data stream and the testing data stream into the database and then compare it in Marple Insight. I think in the coming 10 years, aerospace engineering will be even more data-driven, getting even higher data volumes, higher sampling rates, and maybe also AI can play a role in there by automatically analyzing the data to predict failures early on so that we can prevent them.
Whoa! As an aerospace engineer myself, these projects keep on amazing me. Today we have seen various use cases where teams make use of Marple 2.0, in which we have set a new standard for storing and analyzing time series data in engineering. In 2026, we will continue building on this foundation to get even more value out of your data. Let's have a closer look at the big topics that we will be investing in. First of all, we will focus on system modeling, because this is a major reason why engineers are collecting data. We will enable engineers to fit unknown parameters based on data, evaluate system performance, and compare different tests and simulations. With our event and anomaly detection, we can automate the process of identifying events and faults in the data, increasing the efficiency of engineers. Next to that, we are embracing AI workflows as much as we can. Marple standardizes data, making it accessible for machine learning processes. And by improving our APIs, we will make AI workflows frictionless and faster than ever. We are nearing the end of the presentation. I hope you learned something new today. We got a technical deep dive in Marple DB and Marple Insight by Nero. We saw 2 use cases where Marple is used in the field, and we had a hands-on demo of the Python and MATLAB SDK by Karen. If you have a use case where you think Marple could be relevant, or if you have a question about what we presented, don't hesitate to get in touch with someone of our team. Thanks for joining, and see you soon.
Thank you.